Hey folks, today I'm going to share an Excel solution to something that really piqued my interest over the last week or so ago, and it's a story about a very interesting person called Marilyn Vos Savant. You can find out about Marilyn right here on YouTube. So this is, she was actually a person who had the highest IQ ever, and was asked to solve a problem, and the problem was controversial, and she gave the right answer to the problem, and a bunch of mathematicians said she was totally wrong, including university professors, and sent her some critical statements on that. And only years later did they actually check the math and find out that she was right. So here's a link to the video. Check on that. It's called the Monty Hall Problem Explained. You will find out how she was very quick to get the right answer. And I'm going to show you in Excel how to do that. But this is the background.
French means learned. Learning came easy to her, considering she has an IQ of 228.
So an IQ of 228. You can also look her up on Wikipedia, Marilyn Vos Savant. Let's turn over to Excel to describe the problem. So here is the problem. There's 3 doors, you're on a game show, and you have to pick which door you think the prize is behind, door 1, 2, or 3. So as you could probably figure out, you've got a 33% chance of getting it right. So the prize could be in either door. So there's 2 doors lead to nothing, 1 door gives the prize that you're looking for. And so the simple way to prove this out is to actually just go through every permutation. So at every single time I can guess door 1, 2, or 3, and the answer could be 1, 2, or 3. So if I'm lucky, and that's what this row of the table shows, in the first permutation I pick 1, the actual winning door is 1. If I stay with that, then I'm going to win. But what typically happens is the game show host reveals an incorrect door. So he will, in this case, reveal either door 2 or door 3, and ask me if I want to change my mind. And that's what makes for good TV, because if I change my mind and I got it wrong, I'm going to feel like a fool for doing that. But if I change my mind and I got it right, I'd feel really good. So the thing to know here is the host always reveals the door which is an incorrect answer, and then you're left guessing. Well, let's say he reveals door 3, and you know that's not a valid choice. Then you've got a choice of door 1 or door 2. You think it's a 50-50 chance. You may or may not stick with door 1 or door 2. So this is what happens in the first permutation. In this case, if you were to switch to the new option, you would lose. But let's look what happens if we go to a second option. So a second option is this, and it's revealed here. So door 1 is the right answer, but you actually pick door 2, but the prize is still behind door 1. What Monty is going to reveal is he's going to reveal door 3, and you're going to see door 3 as a non-option. So you're here, and then you're going to give you a choice of, do you want to stay with what you picked, door 2, or do you want to go with the new door, door 1? In this case, if you switch, you win. Now the same thing happens on the third permutation. The third permutation is the answer's still behind door number 1, but you then initially picked door number 3. Monty's going to show you door number 2. So your only option is, do you stick with your original pick in door 1, or do you go for door 3? In which case, switching gets you the winning answer. You can do this for all of the permutations. So the next set of permutations is if the winning door is number 2. And if the winning door is number 2, you can still pick 1, 2, or 3. But what you'll notice here is that as you go through all of the permutations, if you stick with your original pick, then you're only going to be right 1 in every 3 times, because there's 9 permutations and there's 3 doors, so you're only going to be right 1 in every 3 times. But if after Monty reveals one of the options that's wrong, you're actually better off switching. So you're actually twice as likely to succeed if you switch. So now you know how it works out. You can just simply do it by doing each of the individual calculations. You can see how Marilyn was right. What's equally puzzling is, why did it take these maths professors so long to figure it out and thought that she was wrong? It's interesting. You can see here I sort of do a 10-door problem. So imagine, you pick door number 1 as your starting point, and let's say the real answer is in door number 10, which is, and then Monty, after you've made your original pick, Monty then goes through and reveals all of these doors that have got the wrong answer. That's essentially the same thing. Then you actually know that the answer is either the one you picked or the one that you didn't. Now, here's the interesting thing. When you pick this first door, you had a 1 out of 10 chances of winning. So your chances of winning were 10%. But what you did notice is that the other population that you weren't able to pick, that had a 90% chance of winning, right? So all of that was 90%. So when he reveals that section of the population, he reveals all the wrong choices to give you another option, you know that 90% has actually got, most likely, going to have the winning choice in it. So that's why it makes sense to always go with the option, the second option that they reveal, because the winning choice is much more likely to be in this segment, all of the blue doors and the purple door, than it is to be in your original segment. So that's what's exciting about this. It actually tells you that faced in this scenario, the best strategy is always to switch. You actually think it's 50-50, but it isn't. The probability of winning is much better once they've eliminated all the bad options in the other section you weren't able to pick. So I hope that makes sense. As I mentioned before, take another good look at the video. I'll put the link into the video in my final video that I post. But I hope this intrigues you and actually shows you that you can actually do this calculation yourself. You don't need to be a learned math professor. You can just simply write down every permutation, what you would pick as the initial pick, and then what you would pick if you then had a second choice. It's actually quite easy to solve. So good luck and have fun.